Hi everyone, welcome to Lecture 27 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will look at some examples of Redox reactions, and we will also try to study some oxidation reduction problems. Let's look at this example of Redox reaction. Iron 2 oxide plus carbon monoxide. The oxidation number for iron here is +2. That of oxygen is -2. The oxidation number for carbon here is +2. That of oxygen is -2. Iron has oxidation number of 0 here, carbon +4 and oxygen -2. So the oxidation number for iron has decreased from +2 to 0. Remember that decrease in oxidation number is reduction. Therefore, we say that iron has been reduced because its oxidation number decreases from +2 to 0. For carbon, its oxidation number increases from +2 to +4. Therefore, oxidation has occurred because oxidation is increase in oxidation number. Let's have a look at another example. Let's have a look at another example of redox reaction. So here you have CO2 plus H2 gives carbon monoxide plus water. The oxidation number for carbon here is +4, here it is +2. So there is a decrease in oxidation number. Therefore, reduction has occurred here as oxidation number decreases from +4 to +2. For hydrogen, its oxidation number here is 0, but here it is +1. Therefore, oxidation has occurred for hydrogen because its oxidation number increases from 0 to +1. And remember that increase in oxidation number is oxidation, while decrease in oxidation number is reduction. In any balanced redox equation, the number of electrons gained must be equal to the number of electrons lost. This means that the number of electrons in reduction must be equal to the number of electrons in oxidation. So you need to always bear this in mind. We now look at oxidation reduction problems. If you are asked to identify the oxidizing agent and reducing agent and to determine what is oxidized and what is reduced, you start by assigning oxidation numbers to each element. Here, magnesium has oxidation number 0, nitrogen has oxidation number 0. In this compound, magnesium has oxidation number +2 and nitrogen has oxidation number -3. For magnesium, its oxidation number increases from 0 to +2. Therefore, magnesium is oxidized. And magnesium is the reducing agent because a reducing agent is oxidized during a chemical reaction. So magnesium is oxidized and is also the reducing agent because a reducing agent is oxidized during a chemical reaction. For nitrogen, the oxidation number decreases from 0 to -3. Therefore, nitrogen is reduced because reduction is decrease in oxidation number. So nitrogen is reduced and nitrogen is the oxidizing agent because an oxidizing agent is reduced during a chemical reaction. So magnesium is oxidized, nitrogen is reduced. Magnesium is the reducing agent, nitrogen is the oxidizing agent. Let's have a look at another example. Determine what is oxidized and what is reduced in this equation, and identify the oxidizing agent and reducing agent. So we follow the same method. We first of all assign oxidation numbers to all elements in both the reactant and the product side. So iron has oxidation number 0 here. Oxygen has oxidation number 0 because it is in its elemental state. Iron here has oxidation number +3 and oxygen here has oxidation number -2. For iron, its oxidation number increased from 0 to +3. So iron has been oxidized. And since iron is oxidized, iron must be the reducing agent because a reducing agent is oxidized during a chemical reaction. So iron is oxidized and iron is the reducing agent. For oxygen, its oxidation number decreased from 0 to -2. Remember that decrease in oxidation number is reduction. Therefore, oxygen has been reduced. And since oxygen has been reduced, it must be the oxidizing agent because an oxidizing agent is reduced during a chemical reaction. So, iron is oxidized, oxygen is reduced. Iron is a reducing agent, oxygen is an oxidizing agent. Now we look at electron half equations. What is an electron half equation? An electron half equation shows what happens at one half of the reaction. Every redox reaction is made up of two half reactions. In the first half of the reaction, electrons are lost, and we call this the oxidation process because oxidation is loss of electrons. In the second half of the reaction, the electrons that are lost in the first half are gained in the second half, and we call this process reduction because reduction is gain of electrons. So an electron half equation shows us what happens at one half of the reaction because every redox reaction is made up of two half reactions. So in one half of the reaction, reduction takes place, and in the second half of the reaction, oxidation takes place. So let's have a look at this example. So here you have copper with 2 plus charge plus magnesium. Its oxidation number is 0. The oxidation number for copper here is 0, and that of magnesium 2 plus is 2 plus because the oxidation number of monoatomic atoms are equal to their charge. So the charge here will be the oxidation number. The same thing is applicable here. The oxidation number for this monoatomic ion is 2 plus. So equation shows that magnesium has lost 2 electrons, that's why it's Mg2 plus, and copper ion has gained those 2 electrons. That's why copper here does not have any charge. So magnesium has lost 2 electrons and the copper 2 ion has gained those 2 electrons. So the half equations for this reaction are: in the first half of the reaction, magnesium will give out 2 electrons. So this is the 2 electrons that are lost by magnesium. And when magnesium loses this electron, it will become positively charged. That's why it's magnesium 2 plus. And in the second half, copper will gain those 2 electrons. And when copper gains those 2 electrons, it will become neutral. So this is what we call half equation. So in one half, oxidation occurs, and in the second half, reduction occurs. We already said that oxidation is loss of electron, and that when electrons are lost, there is increase in oxidation number. So why is it so? The reason is because since oxidation is the loss of one or more electrons by an atom, and when an atom loses one or more electron, its oxidation number increases, and that element is oxidized. So what it means is that for magnesium, when it loses 2 electrons, its oxidation number increases from 0 to +2. Hence, we say that magnesium is oxidized. On the other hand, for reduction, which is gain of electron, when an atom gains one or more electrons, its oxidation number decreases. For instance, here, copper has gained 2 electrons and its oxidation number has decreased from +2 to 0. So this is the reason why oxidation is loss of electron and increase in oxidation number. Now we look at how to balance redox reactions. There are 2 methods used to balance redox reactions. One is the oxidation number method, and the second is the half reaction method. And we will look at these 2 methods one by one. So we start with the oxidation number method of balancing redox reactions. Okay, the most important point to remember when using oxidation number method to balance redox reactions is that the overall charge for the total of all oxidation numbers must be 0. This means that an increase in oxidation number for the oxidized atoms must be equal to the decrease in oxidation number for the reduced atoms. So it is very important to always remember whenever you are using oxidation number method to balance redox reaction that the overall charge for the total of all oxidation numbers must be 0. We now look at the steps that we must follow whenever we are balancing redox reaction using oxidation number method. So the steps are: first, you need to write the unbalanced equation. That's the first thing you do. At first, you don't need to balance them. You just need to write the unbalanced equation. Then the second thing is that you need to find the oxidation state of all atoms in both the reactant and the product side. That's the second thing you do. Then the next thing is to write the electrons that are gained and those that are lost. After that, then you add coefficients to make the number of electrons that are lost to be equal to the number of electrons that are gained. Then the final thing is then to balance the rest of the equation by inspection. So we will apply all these rules in some examples. So we now look at an example on how to use oxidation number method to balance a redox equation. So if you're asked to balance this equation, the first thing you do, you write the unbalanced equation down, then you write the oxidation number of each element for both the reactant side and the product side. Here, copper has oxidation number 0. The oxidation number for silver here is +1. Here the oxidation number for silver is 0. And here the oxidation number for copper is +2. For silver, its oxidation number decreased from +1 to 0. Remember that decrease in oxidation number is reduction. Therefore, silver has been reduced. And since silver is reduced, it must be the oxidizing agent, because an oxidizing agent is reduced during a chemical reaction. For copper, its oxidation number increases from 0 to +2. Remember that increase in oxidation number is oxidation. Therefore, copper has been oxidized. And since copper is oxidized, it must be the reducing agent, because a reducing agent is oxidized during a chemical reaction. So in this equation, silver is reduced and silver is the oxidizing agent. Copper is oxidized and copper is the reducing agent. This means that 2 silver ions must be reduced for each copper oxidized, because copper has 2 positive and silver has 1 positive. So the balanced equation is, you just put 2 as a coefficient for Ag+. So this way, the number of electrons lost will be equal to number of electrons gained when you put 2 for silver here and 2 for silver here on the product side. So in this way, the equation is balanced. So these are the steps that you need to follow whenever you are asked to balance a redox reaction using the oxidation number method. So first you write down the unbalanced equation, then you write the oxidation numbers for each element in both the reactant and the product side. Then you find out which element has been reduced and which has been oxidized, and also find which element is the oxidizing agent and which is the reducing agent. Then finally, you add coefficients so as to make the number of electrons lost equal to the number of electrons gained. So here we have added 2 for silver because we have copper 2 plus here. So we need to balance the number of electrons lost with the number of electrons gained. So copper 2 plus and Ag plus. So this is 2 and this is 1. So both need to be balanced. So that's why we have added 2 for Ag plus here, and we have added 2 for silver on the product side as well, because 2 silver ions must be reduced for each copper that is oxidized. Let's look at another example. If you are asked to balance this equation using the oxidation number method, the first thing is to identify the atoms that have changed their oxidation numbers. So we write down the oxidation numbers for each element on both the reactant side and on the product side. The oxidation number for zinc is 0. The oxidation number for hydrogen in HCl is +1. That of chlorine is -1. The oxidation number for zinc here is +2. That of chlorine is -1. The oxidation number for hydrogen here is 0. So for zinc, its oxidation number increases from 0 to +2. Remember that increase in oxidation number is oxidation. Therefore, oxidation has occurred for zinc. For hydrogen, its oxidation number decreases from +1 to 0. Remember that decrease in oxidation number is reduction. So for hydrogen, reduction has occurred. So the next step is to equalize the changes in oxidation number. Each zinc atom has lost 2 electrons, as you can see from the equation here, and each hydrogen atom has gained 1 electron. So we need to balance the positive and the negative charges. So we will continue on the next page. Okay, you need 2 atoms of hydrogen for every 1 atom of zinc. This will give +2 and -2, which is then balance. So the last step is to insert coefficients to balance the positive and negative charges. So that coefficient is to insert 2 here as coefficient for HCl because you need 2 atoms of hydrogen for every 1 atom of zinc. So if we do this, we will have zinc plus 2 HCl gives zinc chloride plus H2. So this is the balanced equation. So this is a practice problem. You try to balance this equation using the oxidation number method and see whether you will get the correct answer. So this is the solution to the practice problem. Try to solve it first and then have a look here to see if you got the correct answer. Now we look at balancing redox reaction using half reaction method. So we have already looked at the oxidation number method. Now we will look at the half reaction method. Right, to balance redox reaction using half reaction method, you have to follow these steps. First, you write the half reaction, then you balance all atoms except oxygen and hydrogen. Next, you balance the charge, then you add coefficients so that both half reactions share the same number of electrons. The next thing then is to balance oxygen and hydrogen by adding OH if alkaline. If acidic, you add H+, but if neutral, you add water. After that, you join the half reactions together. You combine the first half of the reaction and the second half of the reaction. And then the last thing is to cancel like terms on both sides. So we will apply all these rules in the next slide. Okay, let's look at an example on how to balance redox equation using half reaction method. So if you have this equation and you're asked to balance it using the half reaction method, first you write down the oxidation numbers of all the atoms in both the reactant side and the product side. Aluminium here is 0, the oxidation number. The oxidation number for manganese here is +4. That of oxygen is -2. That of aluminium in this compound is +3 and that of oxygen is -2. The oxidation number for manganese here is 0. So aluminium gives out 3 electrons because it's plus 3, and manganese accepts 4 electrons because it is plus 4 here, and here it is 0. So 12 is the lowest number divisible by both 3 and 4. So for aluminium, if you divide 12 by 3, you will get 4. So you need 4 aluminium atoms. For manganese, if you divide 12 by 4, you will get 3. So you need 3 manganese atoms. So you put these numbers as coefficients on the reactants. So we put 4 for aluminium that we calculated here, and we put 3 for MnO2 that we calculated here. So, but the equation is not yet balanced. So the last thing you do is to add coefficients so as to make the equation balanced. So we have 4 aluminium here. Here we have only 2. So to balance it, we need to add 2 here. So if we add 2, we will have 4 aluminium here, 4 aluminium here. And here we will have 6 oxygen here, and we'll also have 2 multiplied by 3, 6 oxygen. Also here, manganese is 1 here, but it's 3 here. So to balance here, you need to add 3 here. So if you add 3, we'll have 3 manganese here and 3 manganese on the reactant side. So in this way, the equation is balanced. So this is how to balance the equation using the half reaction method. Right, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture. Bye.